Hello, this is Mrs. Decker, and in this video we'll focus on Objective 3B, calculating the equilibrium constant when given the equilibrium concentrations of reactants and products, and 3C, determining whether products or reactants are favored based on the equilibrium constant. Okay, so before we jump into 3B, we want to refresh 3A, which is on writing the equilibrium expressions. So we have our equilibrium constant, KEQ, is equal to the concentration of the products on top, and the CO is going to be raised to the second power because of the coefficient, divided by the concentration of the reactants. Now we would not include SN because it's a solid, so the bottom is only going to have CO2 raised to the second power. So this is the equilibrium expression for this reaction. Okay, so if the equilibrium concentrations are given for a specific reaction, we can plug them into the equilibrium expression that we write, and then we can calculate KEQ. So here is our first example. So this is our reaction. 2NH3 produces N2 plus 3H2. And then the problem says, what is the equilibrium constant for the above equation if the equilibrium concentration of NH3 is 0.1 molar, N2 is 0.5 molar, and H2 is 0.5 molar. So we need to start by writing the equilibrium constant. So KEQ is equal to the concentration of N2 times the concentration of H2 raised to the third power, divided by the concentration of NH3 raised to the second power. So now we're going to plug our concentrations in. And now you can plug that all into your calculator and calculate it, and you should get 6.25, and the equilibrium constant has no units. Right, so 2C is on determining whether products or reactants are favored. So we do that by looking at the KEQ. So the KEQ is greater than 1, which means that products are favored. And we'll look at that more in just a minute. Okay, so sometimes you will be given the equilibrium constant and most of the other concentrations and be asked to find the concentration of a specific reactant or product. Okay, so here is our next example. It says a mixture of SO, O2, and SO3 is allowed to reach equilibrium. If the concentration of SO2 is 0.5 molar and the concentration of O2 is 0.1 molar, what is the concentration of SO3 if the equilibrium constant is 1.65 times 10 to the negative 8th? So the first thing we need to do is write our equilibrium expression. So KEQ is equal to the concentration of SO3 to the second power divided by the concentration of SO2 to the second power times the concentration of O2. So now we're given the equilibrium constant, we're given the concentrations of SO2 and O2, and we're asked to find the concentration of SO3. So let's plug all the information in. And now we have to solve for the concentration of SO3. Okay, so when you do the math, you should get the concentration of SO3 to be 2.03 times 10 to the negative fifth molar. And this should have units because it is a concentration. So 2.03 times 10 to the negative third molar is the concentration of SO3. Make sure you're being careful with your exponents and getting rid of them correctly. Okay, so now we're going to talk more about objective 3C, determining whether reactants or products are favored in the reaction. So if KEQ is greater than 1, the products are favored at equilibrium. If KEQ is less than 1, the reactants are favored at equilibrium. And if KEQ is equal to 1, neither products or reactants are favored at equilibrium. All right, so now we're going to look at some equilibrium graphs. So for the first one on the left here, we can see that the dotted purple line here is when we have reached equilibrium. The product line is higher, has greater concentration than the reactants. So that means that the products are favored, which would mean that the KEQ is less than 1 for this reaction. The second graph on the right, again, the purple line is where we have reached equilibrium, and the concentration of the reactants is higher than the concentration of the products for this reaction. So the reactants would be favored, which means that the KEQ would be less than 1 for this reaction. And then for this graph, again, the purple dotted line is where we are reaching equilibrium, and neither reactants or products are favored here because the concentrations are equal. So this would mean that our KEQ is equal to 1. So you have some practice to work on in your packet. Go ahead and do that, and then let me know if you need help.